This is our Grizzly Hacks 2020 Python workshop. We're going to go over some basics in Python, try to get you just kind of comfortable with Python, regex, and web scraping. So our objectives, we're going to try to show you some basics about Python. You know, if you're debating whether or not you want to dive into Python, if you've already started it, we're going to try to give you some basic information to help you make a decision and get you a little bit more comfortable with it. We're also going to, by the end of this, use it for a real-world application. That's going to be the data scraping part of this. And I'm going to do a live demo of writing a script that does web scraping. And then Dr. Ganai and Dr. Anka and I will help each of you as we help you do your own Python script that does the same thing. So hopefully by the end of this, you'll walk away with a little bit of knowledge about Python and the ability to write your own program that has real-world use. So we're going to teach you a little bit about regex. What regex is basically a way to articulate, to describe patterns in text. So if our goal here is to parse the titles out of this text, we first need to determine what the pattern is. We can see just by looking at it that the pattern is, you've got the word title, followed by a colon, and then a space, and then the title of our book. So to convert that into regex, we will use this, title, colon, space, and then this regex pattern. And again, a regex pattern is really just a set of standards to articulate, to describe a pattern in text. Then we're going to go over data scraping. Data scraping is just a little multi-part process where you find data. You have to figure out how the request is happening, whether you use Wireshark, a web inspector, and your web browser, or if you're lucky, you just Google it. You look it up, figure out how to send this particular request. Then you write code to make the request happen. You're going to get a response back. You need to figure out how to process the response. And then, in all likelihood, you want to do something with it. So you format the data, put it into a meaningful format, and then you use it. So let's look at the first part of that. We're going to go over some Python stuff. So first off, the setup. We already talked about this a little bit. You'll want to download Python. You go to python.org, and then you'll just follow the instructions there based on your platform. Whether or not you've got Windows, Mac, Linux, it runs on all platforms. You'll just follow the instructions based on what you've got. You'll need a way to edit and run Python code. So you'll need PyCharm if you like to use IntelliJ. There's a Python plugin for that. If you like to use Eclipse, there's a plugin for that called PyDev. Out of the three of those, I would thoroughly recommend PyCharm because I believe it comes automatically with Python packaged into it. And it's meant specifically for Python, so it's got a few really good features aimed specifically at Python. The other option is an online interpreter. My favorite one is REPL.it. It lets you edit code just in the browser. You can run it in the browser. I believe I've got REPL up and running. So what that looks like is this right here. And I'm actually going to, for the challenge, I will ask at the end of this, I'll ask that you do use this. That way you can share the code that you write with us for review. There's a way to share within this. Oh, actually, I think you just give someone the URL. But anyways, you write your Python code here, and then you can run it. I'll click this run button. And what this does is it sends a request to google.com, and then it prints out the response. So this is all the HTML from Google. So it's super easy. You just load it, you write your code, and then you run it, you go. There's no setup, no download required at all. I don't think you really even need to make an account for this. I did make one just because I use it often. But for the purpose of this, I think this would be easier. And like I said, for the end, I am going to ask that you use this so that you can Here we go, share, so that you can share your code with us for a review. Cool. So those are your options. If you do end up using Python more in the future, definitely recommend downloading it, installing it. But for the purpose of this workshop, it can be a little bit of a hassle. So let's talk about Python. Python is what's called an interpreted language. It's also called dynamically typed. You've got your compiled languages like C, Fortran. Those are compiled directly into machine code. Python, on the other hand, is dynamically interpreted. What that means is it's not compiled directly into machine code, but you've got the Python interpreter that translates it into machine code as the program runs. So just like if you're sitting with someone who speaks a foreign language, you might have an interpreter sitting there translating for you, translating for them in real time as the conversation's happening. That's what Python does. The Python interpreter, as the program is running in real time, converts it into machine code for your computer to run. Why does it do that? So for a compiled language, your variable types are defined. They're hard-coded into your code. So you define this variable x as an int, that variable y as an int. And if you try to add them together, we know that the output z is going to be an int. And over here for Python, or any interpreted language, Perl, Ruby, your variable types can be dynamic. So x equals 2, that's an int. If we want, we can do x equals 2, but later on in our code, we'll say y equals hello. Later on in the code, though, we can say x equals world. We can change the type. You can't do that in Java. Once you declare your variable as a certain type, it stays that type for the rest of that section of code. So this provides, when you're working with an interpreted language, it provides a little bit of flexibility. The general philosophy when working with Python is that you as a developer should have pretty much full control over every aspect of what's going on. If you want to make a mistake, that's up to you. If you would like to write a method that is supposed to take as input a couple of integers and add them together, and then you want to feed a string into that method, you should be able to. It's probably going to screw up your code, probably going to cause an error, but you should be allowed to do that. Java is going to stop you from doing that. If you write some code where you tell Java that your method accepts an integer, and then you try to elsewhere in your code make that that method accept an int, it's going to throw an exception, and it's just not going to compile. So with Python being interpreted, it allows a little bit more flexibility. It requires that you be a little bit more careful, but it does also save time. You're able to change things as you want to, as long as you know what you're doing, and you're making sure that the right variables are going in the right places. It makes it faster and quicker to write code. Again, it gives you more flexibility, more options. You just have to be a little bit more careful sometimes. And when you're dealing with a small program, like 20, 30 lines, it's easy to keep track of it and make sure that things are done correctly. I will say this, when you're dealing with a large program, a large project that spans multiple files and has thousands of lines, using a language where you have to define your variable types, where it's going to give you an error if you try to stick the wrong variable into the wrong method, sometimes you want that for larger projects because it helps prevent errors. That's actually one of my buddies' biggest complaints with interpreted languages is that they don't do that sort of error checking. So I want to actually take a second to talk about that now. When it comes to these interpreted languages, preventing errors due to using wrong data types. Python has something called type hinting. So I just told you that you don't declare the variable type in Python. But through this type hinting, you actually can. It was introduced at somewhere in Python 3, where you can now define the type of variable, the data type for a variable. So here you see we've got our variable x in this method is set to be an int, y is an int, and the output of this method is an int. then it returns x plus y. So then here we create these two strings. First name is a string, Mary. Last name, string, Jane. Then we try to insert these into our add method, which is supposed to only take 2 ints. And with type hinting, our IDE now will give us a warning. It's not an error. It will still compile and it will still run the code. It still gives us that option. If we want to do something that's going to mess up, it still lets us do it. But it does at least give you the warning. That way it helps you catch errors early on, helps maintain structure, helps you with your larger projects, make sure that you can keep track of everything that's going on, help reduce errors without sacrificing the flexibility. There are times with my projects where I do ignore the warnings given to me thanks to type hinting. But it's very rare. You need to have a good reason for ignoring these warnings. But still, at least it gives you the same error checking that compiled languages do, along with the quickness, the flexibility of writing code that you get from interpreted languages. So, looking at data types for Python, these are all of the data types. The ones that you'll usually be concerned with are these first three. You got for your text, you got just simple string. For numbers, you got your normal int and floats. You also have this interesting one for complex numbers. If you want to have a number that that includes a variable, you have the option for that. I've personally never used it, but you do have the option. You've got lists, tuples, and ranges. Lists are the ones that you use most often. Tuple, it's basically the same thing as a list, but it's not meant to be edited. If you've got a set of data that stays the same, you might use a tuple. But usually you'll just use lists. Dicts, dictionary. In other languages, these are called associative arrays. They're also called dictionaries. They're called, like in Java, they're maps, whether it's a hash map or what have you. You'll see these in a lot of languages. Super useful, associates a key with a value. Then you've got sets. Sets are a lot like lists, except they're unique, and they have a couple of really powerful methods attached to them. So if you do have a set of data that you want to make sure it's completely unique, suppose I have a list of nums, 1, 2, 3, 3. I want to make sure this is unique. I can convert it to a set, and boom, it's now only got unique values. And we've got our booleans, true, false. For binary data, like if you've got a blob of data, you'll use bytes. Got a byte array. You've also got this thing called memory view, which gives you really low-level access to managing the memory that's behind certain objects. You can release an object from memory using this. You can figure out an object's location in memory. Again, the only ones that you really ever use are string, int, and float, list, and dicts. These 1, 2, 3, 4, 5 are the ones that you'll use the most often. The only ones that you really need to worry about. So let's look at a little bit of Python syntax. I think I did hear a couple of, okay, cool, no one posted in here. Yeah, so if statements. Python does aim to be fairly easily read. So right here, an if statement is going to take the format if, then you'll put your condition, then a colon, and of course.
Although we were still hearing you, I think, Sean.
I think it's only Sean that crashed.
Yeah, sorry about that, guys. Oi. Yeah, Discord. I don't know if Dr. Ganai has this issue, but for me, Discord on Linux tends to crash every randomly, like 10 minutes to every hour.
Yeah, it does that to me too. Like when I'm sharing my screen, it crashes and comes back.
Yeah, that's fun. Yay,
Yeah, that
Linux.
seems to only happen whenever you're doing like a voice call, I've noticed.
Yeah, it's only with voice call, screen sharing, that kind of thing. Yeah. The rest of the time is pretty fine, but oh well. All right, where's the presentation? Where'd it go? Ah, can't find our presentation. All right. Here. Went away. Yeah, it just okay. Well, here. Sorry about this, guys. All right, we were looking at syntax right here and present. There we go. Okay. Awesome. So back to the presentation. So yeah, Python aims to be fairly easy to read and understand. Syntax for any if statement is you'll have if followed by your condition, a colon, and then your block right here. One interesting kind of different thing about Python is that it uses white space to define sections of code, to define different blocks of code. In a lot of languages, you'll use curly braces. So, for Java, you'll have your if statement, and then you'll have a curly brace. Then you put all of the code that you're going to use for your if statement after that, and then you'll put a closing curly brace. For Python, you use white space, and anything under here that follows with that same indentation level is part of our if block. So I think that for Python, they want to try to make sure that code stays looking pretty. I know for me, when I first started coding, I didn't indent anything. I didn't indent well. Once I started using Python, it forced me to start indenting my code. So my code, by just virtue of using Python, started actually looking better and more legible. So I think that's why they do it. So right here, we're checking we create this list, names, it's got a few names in it, and we check to see if John is in that list. And if it is, then we'll print John exists, and our output is John exists. So yeah, this is just an easy way to check if a list contains something. All right, so for loops. So we've got two types of loops here. I think in Java we call this, or at least Dr. Price called this the enhanced for loop, where you're looping over a list and you loop over it with a variable. So every time this loop runs, this variable name is going to be just each next item in our list. So the first time it runs, name will be John, then it'll print Ellen, then Charlie. And this is more like your typical loop that you see. Usually you'll see a loop that says something like int I equals 0, then while I is less than a number like 5, I plus plus. This is basically the same thing, except in Python we write it like this. For I in range 0 will be your starting condition. You're starting at 0, and you're going while I is less than 5. So we print I starts at 0, and it prints all the numbers that are less than 5. There is an option to do a little bit more with it. So like when you have your int I equals 0, I less than 5, I plus plus. If you want, with a loop like this, you could have it skip by 2. You could have it increment by 2 every single time if you want it, by using the last part of our for condition. You could have it skip by 3, whatever. And you do have that flexibility here as well for I in range all you would have to do is say 0, 5, and let's see, print I. All right. The only thing you would change is you would add something to the third part, just like with your Java for condition. For the last part of it, you'll put how much you want to increment by. Increment by 1 is the default, but if we want to increment by 2, then the output looks like this. Start with 0, and then we increment by 2 every time until we hit our condition where it's no longer less than 5. So for a while loop, we put our condition here. In this case, we're doing something a little bit different. We're letting our list be our condition. In Python, a list will evaluate to true or false based on its contents. So if we've got a list that has some stuff inside of it, it converts to true. If our list is empty, then it converts to false. So what this is saying right here is that while our list has some data inside of it, we're going to loop over it. We're going to keep doing this. So the first thing we do is we pop from the name. If you're not familiar with, what pop does, it's the same across virtually every language. Pop just takes the first item out of a list and removes it. 1, 2. So nums.pop will give us the last item. Takes the last item, returns it, and then if we look at it, it's no longer there. So what this is going to do is it's going to take the last item, pop it out, set it to this variable name. We print our name, then it shows us the list of names as it currently stands. So it's only got John in it. Then it starts back over. We pop out the only item in our list, which is now just John. We print it out, John. Then we print out names, and it's now empty because we've popped every item from it. So when we start back at the top, names, since it's empty, evaluates to false, and our loop exits. It breaks. So this is how your while loop looks. It's just while with your condition, and then your code after it. Again, you want to make sure that your indent level stays the same. Method definitions. We already saw one before when we were looking at type hinting, but this is your typical method. You start with the word def, give your colon at the end, and again, you've got your indentation here that stays the same. Notice that we do have nested statements. So here we've got an if statement inside of our definition, and we just increase the indentation level. If we wanted to add more stuff inside of this if statement, we would just make sure that indentation level stays here. And then we want to return back to our definition block. We just go back to the same indentation level that we defined under our definition. As soon as we go outside of that indentation level, once we go back to just no indentation, we're done with the block. So right here, we define our method. It takes 2 parameters, x and y. If x is 0, we just return y. If y is 0, we just return x. Otherwise, we return x plus y. I could have made this simple and just say x plus y, because if x is 0, then 0 plus y is still just going to be y. I just wanted to demonstrate what happens when you do have nested statements. All right, I heard a bunch of stuff. I'm not sure if Discord stopped sharing. No, it's still sharing. Okay, sorry about that. it's giving me a near heart attack hearing all that stuff going on. I guess people are exiting and
You're good, Sean. I was posting stuff.
Cool. Just making sure. All right. Class definitions. So Python uses something called self when referring to instances of a class. Java, I believe Java actually uses the same thing. It's called self, does it not? If you want to refer to an instance variable, you can say self up and then the variable name.
In Java, it says this, right?
This, that's what it is. Thank you. Okay, it's this. But Java has virtually the same thing. It's called this, and in Python, it's called self, but they're the same thing. Slight difference is in Python, the way you declare a method as being a like an instance method, where you need an instantiated object in order for that method to work, is you put self in the definition of the of each function. You pass it as a parameter. So this right here is going to only be used on an instance of a person object. So we declare this method. We give it a method that runs on instantiation. So anytime you create a new person like this, it's going to run this init method. So right here, we're telling it that it's going to be used via self. We tell it that it's going to be used when there's an instance of the object. And we give it a default value for this thing called name. That means that the person has the option of passing in an argument that will be used as the name, or they don't have to. If they don't pass it in, the default name will be Eli. If they do pass it in, we'll use whatever they passed in. So we see that here, the person passes in Jack, and so we say self.name equals, and then we use what they passed, Jack. If we print Jack and then this instance method, get name capitalized, which just returns the name capitalized. So if we use this method, we see it prints out Jack. It prints out what they passed in. We passed in Jack, that gets set to self.name. So when we return self.name.capitalize, it uses the thing that we passed in. If we don't pass anything in, then it uses our default here, Eli, and it prints Eli. When we look for person.name, it prints Eli. And also notice right here, I want to stress this. We're using person.name. Notice that we never define a getter or a setter for our variable here. We have self.name, but we don't define a getter or a setter for it. There's no set name, get name. Python, again, following the philosophy of as a programmer, as a developer, you should have more or less full control over everything that happens within your code. They don't believe in Java's philosophy of hiding certain things. In Java, the purpose of using getters and setters is to hide certain actions from people so that you don't mistakenly set a variable to something that it shouldn't be. But here, Python says, nah, if you want to set it to something crazy, go for it. You have full control over this. So we don't deal with getters and setters. You just get direct access to each attribute, and you're allowed full control over what you do to it. One thing that a lot of people like about Python, you'll see a lot of people showing off, is it can do some really powerful things in just one line. You definitely don't have to remember any of this at all. It's just here to demonstrate some of the stuff that Python can do. So you have a list of numbers, and you want to add 1 to each of them. This syntax right here, an array with this sort of stuff, something for x in nums. Whatever you put here, x plus 1, you could say x plus 2, you could say x dot capitalize if you've got a bunch of strings. It'll go through and it'll change everything inside of this list based on what you put here. So here we say x plus 1 for x in nums, that adds 1 to each item. You got lambda functions, and you do have those in Java as well. You've got them in a lot of languages. They're essentially just one-line methods. This one, lambda x comma y, so it takes 2 inputs, x and y, and it returns x plus y. Notice that we don't have a return statement. Whatever the output is here, that's just going to be what the method returns. And we set this lambda function to our variable add, and we run add 2 and 3, and it outputs 5. So it's a one-line method. You can filter items in a list out using the same notation we used here. We'll say x for x in nums. That means don't change it. Don't do anything to it. Just leave it as x if x is less than 3. So it'll go through. If x is less than 3, then it keeps it. So that just gives us 1 and 2. Here, this one speaks for itself. You can add all the items in a list together. You can reverse a list using this fairly weird notation. Swapping variables, if you've got a equals 1, b equals 2, you can say a comma b equals b comma a, and then their values are switched. There's a lot more than this. You can Google Python one-liners, and it can get crazy, the amount of code that you can condense into a single small space. That's one thing, like I said, a lot of people really like about Python. You can you can make your code just super small. The number of lines that it will take to do something in Java versus Python is crazy. You can really simplify your code if you switch to using any interpreted language, Ruby, Python, whatever. All right, so let's look at regex and let's look at scraping. Scraping is, like I said, it's the process of finding how to get your data.
So, Sean, 1 second, if I can interrupt,
Sorry?
maybe people have questions about general Python before you start regex?
Okay, yeah. Does anyone have any questions about Python? Any of the stuff that we've gone over? Let me check if someone wants they can type.
Yeah, I do have a little question. So
Okay.
what makes lambda functions different from regular functions? Is it just the one-line stuff?
Yeah, it's the fact that you can take a method and you can stick it into the space of just one line. One thing that's kind of nice for is it means that it's easy to use a lambda function and pass it as an argument for a method. So if we have our list of numbers here, we can use this method called map, which is similar to what we did before, looking at one of our Python one-liners. But the way that map works is it takes a function and then it applies that function to, so it takes this input a function and then a list, an iterable. And then it's going to apply that function to each item in the iterable. So if we use a lambda function here, like I said, it just makes it really easy to pass a function as an argument to another method. So we'll say lambda x, and that x is going to be each individual item in our list. And then what do we want to do to it? Let's say x, something simple, x plus 1. So it's a simple one-line function, takes a single argument, which is going to end up being each item in our list. And then we do something to it. Right here, we're just doing x plus 1. Then the second item we're going to pass to map is our iterable that we want to apply that to. If we hit enter, it gives us a map object. Let's convert it to a list. There we go. So it used our lambda function and applied that function to each individual item in our list nums. So each individual item, 1 got treated as x, and we did 1 plus 1 is 2, so on and so forth. So that's one way that you can use lambda functions, is by passing them into other methods as an argument. It's one way in which they're useful. Basically, anywhere where you want to just really quick and easy write a method. Let's see, no messages. Anything else? Okay. So I'll go ahead and move on to the next part, doing regex. Or sorry, scraping. So as I was saying, scraping is the process of finding data, figuring out how to send a request. Then you need to figure out how to handle that request. So you're going to look at the protocol. If you're doing HTTP, you're going to use a certain library to code the request, SMTP, IMAP, FTP. These are all different protocols. And that'll define how you code, how you send the request. It'll determine the tool that you use to send your request. And then you've got to do parsing, which is where you deal with the response. You obtain meaning from the data. The response can come in a lot of different formats: HTML, XML, JSON, CSV. And based on the format for the response, that'll determine the tool that we use to parse the response. So parsing. JSON, for Python, you'll import the JSON library, comes built in. And this is what JSON looks like. HTML, there's also built in an HTML parser. And CSV. CSV is this comma separated values format, where everything is just separated by commas. And there's also a built-in library for that. Python does have the nice advantage where a lot of the stuff that you want to do comes built in. You don't have to go deal with downloading any external libraries, but if you want to, it is pretty easy. One thing that I want to point out here is that if you notice, all of these do follow certain patterns. I mean, that's the whole purpose of having a defined standard, is that there's a standard format that it follows. For JSON, if we wanted to grab the name, we've got our name followed by a colon and then in quotation marks the name. Here, for the HTML, all of our tags are inside of these brackets, and everything, all the text is outside of our brackets. For CSV, if again we wanted to get the name, we're looking at the start of the line, everything from the start of the line to the first comma. And I point this out because while you can use each of these different tools, each of these different libraries to extract data from these different formats, there is one tool that extracts data, extracts value from any sort of data format. No matter what you throw at it, if there's a pattern there, you can extract meaning from it. And that's, of course, using regex. In Python, that is the re package, re for regex. So that covers any use case where there is a pattern that that you can apply to your text. So again, for this one, our regex pattern that we could use would be, like I said, quotation marks, name, colon, quotation marks, and we want to keep everything inside the quotation marks. So we use this pattern, and we will go over a little bit more detail what each of these patterns means. For HTML, suppose that we've got this name that we want to extract. The pattern that we see, it is preceded by this span tag where they say class equals client. And then there's a closing span tag, and we want to keep everything between those two. So we have the opening span tag, and then we've got the closing span tag, and we've got this, everything between the two tags. And then for CSV, like we said, we want to start with the start of the line and then go up to the first comma. So this little notation here, the caret, means start of the line, and then we get everything up to the first comma. Yeah, so finding patterns is basically about noticing what stays the same and then what changes. So in each of these cases, this part right here, the name, the colon, the comma, that will always stay the same. The thing that's going to change is John Smith. That might end up being Mary Lou or something. So the stuff that stays the same, you put here as just plain normal text, and the stuff that changes, you'll put a regex pattern in its place to match whatever this is. So we have our regex cheat sheet. Regex has a few different, a lot of different ways to to signify, to denote different types of text. Right here, we've just got the letter A means just the letter A. AB is a string AB. You can use this right here, called a pipe, and that basically means or. So you'll get A or B. We use backslashes for all of our special characters with special meanings. \D gives you a digit. Capital D is a non-digit. This is white space, which is going to cover a tab character, a new line character. And this will be anything that's not white space. Any word character. So that's going to be an alphabet, a number, or an underscore. And then a capital W is any non-word. We've got quantifiers, which say how many of these things do we want to match. So let's go ahead and say text. I'll show you some of these. Text equals hello world. So a star after any of these or after an A will mean there's going to be 0 or more. So a star after a period, which we saw several of before, a star after a period means 0 or more of anything. The period matches any single character. So this means anything, any single character repeated 0 or more times. This question mark it's got a couple of different meanings depending on where you place it. If you place it like we did here after one of these quantifiers, it's going to mean non-greedy. If you place it after anything else, any character, any string, it's going to mean 0 or 1. It means the thing might not be there. So if we have, for instance, HTTPS, whenever we have a URL, often we'll have either HTTP or HTTPS. The S might be there. So in that case, we'll put a question mark. If we want to match a URL, we'll put a question mark after the S. That means there might be 0 S's or there might be 1 S. It might be there is what it means in that case. Like I said, if we place it after one of these quantifiers, it means don't be greedy. Usually what's going to happen is if, suppose we have a regex where we say div, and then we go until we see this. This will match until the very last closing div that we find. I think we've actually got an example of that here. Yes. So if we say opening HTML tag, star and asterisk, and then a closing bracket, that's going to start off here at the beginning, our first opening bracket, and it's going to go not to this one, but to the very last one that it finds. If we instead use this question mark, it's going to make it not greedy. Going to say, instead of stopping at the very last one you find, stop at the first one you find. So then it's going to start here at our opening bracket, and it's going to stop at the first closing bracket that it sees. So that's what non-greedy means. We've also got these curly braces, which will match a certain number of characters from our previous statement. So if we've got A and we want to match 3 in a row, we'll do this. This will match 3 A's exactly. It's got our commas there, so this will match 3 to 5 A's. It will match 3 A's in a row, 4 A's in a row, or 5. This notation right here means 2 or more, so 3 comma, that'll match 3 A's, 4 A's, 5 A's, so on. And then if you put the comma in front, that'll match up to 3. So it'll match 1A, 2A, or 3 A's. So yeah, then just a few more examples. Right here, if we want to get this word title out, we'll say class equals quotation mark, quotation mark. Notice we have parentheses here. Parentheses means that we want to keep the stuff that we put parentheses around. This right here, class equals quotation mark, that's going to be part of our search pattern. We need to make sure we find class equals quotation mark, and then we'll find this right here, any character repeated 0 or more times until the next quotation mark. So it's going to match everything inside these 2 quotation marks, but we tell it that we want to keep all this stuff inside the 2 quotation marks. So it's going to drop the class equals quote, it's going to drop the second quote, and it'll just give us, oi, that is not what I wanted. Go back. It's just going to give us the title, the stuff inside the quotes. For this, hello world. It matches from the first closing bracket to the second opening bracket. But again, we use these parentheses to tell it we want to just keep the stuff inside there. So it just returns hello world, and it drops the opening and the closing bracket. So like I was saying for this question mark, suppose we want to match a bunch of URLs. We'll say HTTPS question mark. That'll match any of these URLs that start with HTTP and then do or don't have an S. Notice it matched the first one, matched the second one that does have HTTPS, but it doesn't match the FTP because that doesn't match this pattern here. And we told we want the colon, // and then everything after that till the very end. So that will give us these 2 URLs, not the FTP one. This right here says that we want to start with the colon, // then everything up to question mark, the first slash that we find. and we just want to keep this stuff. We want to drop the :/ and the first slash that we find. So that's just going to give us the domain. We start with ://, then we go until we find the first slash that's right here. And then we just keep what's in the middle. That's going to be google.com, reddit.com, and cdn.server.com. And suppose we want to get the, right here, this one contains a query string. So if we want to get the query string out, we'll say \?. Why do we use the backslash? Because the question mark actually means something in regex. It means 0 or 1, like right here, or it means non-greedy, like right here. So to tell regex that we want a literal question mark, we're going to use this backslash. And then we just want everything after the question mark. Everything after it is going to be part of our query string. So that will give us everything from this question mark on to the very end, which is what we see right here. Cool. So any questions about any of this, regex or parsing? Any questions from anyone, or data scraping? Any questions about that? Make sure I'm still, yep, okay. Cool, okay. So I guess there's no questions?
Well, you are still there. I'm not sure, maybe people are overwhelmed with a lot of content, so I guess a hands-on section could help it soon, I assume. If there's any feedback from the audience, how is everything going?
Okay. So,
That's that.
okay. Yeah, there is a decent amount when it comes to how complex regex patterns can get. On the plus side, this sort of stuff right here is pretty much the majority of what you'll use. This little pattern right here, dot asterisk question mark, that will get you through a whole lot. This is honestly the majority of what I use in all of my code. Anytime I want to get some data out of some HTML, it usually ends up looking like this, where you've got some HTML tag before it, then I've got the data I want to use right here in a closing tag. So I'll just put the entire HTML tag before it, kind of like this example. I'll put the entire first HTML tag before, and I'll put this dot star question mark notation, and then the closing tag, and then a couple of parentheses right here to tell it that I want to keep it. And this right here, this one thing, will get you through probably about 90% of what you want to do with regex. The rest of it just gets kind of complex as need be on a case-by-case basis, but this sort of stuff right here will get you through the majority of anything that you want to do. Okay, so for this part, I wanted to go ahead and throw some of this together and use all of it together to show you exactly what it looks like when you want to grab some data from a web. So I found this simple website, Weather Report for Kids. It outputs just the weather for where you're at in a nice, simple format.
Before you start that, Sean, can I say something?
Sorry?
Before you start that part, so we're approaching 1 hour. So some people may not have the time. So if they're leaving, just to note that there's a survey in the workshop channel. So if before leaving, please do the survey for us, so we get some feedback from you. Okay? And if you stay, there's more content, and Sean is just starting the hands-on part.
Yeah. So please do fill out that survey before you go. I do apologize for the length of this. I was hoping to keep it around an hour. We are just about done. I'm going to go through this process right here of putting all the things together.
I think 90 minutes is a good workshop. It's not too long, but I don't know if people have the time, so that's why I was just announcing.
But there's just 2 parts left. I'm going to go through this process, putting everything together. I'm going to show it to you using the some nice online tools, something that any of you guys can use without downloading anything, and show you how to write a script to get information from a website. So I'm going to use repl.it. I'm going to use pythex.org, and there will be a list with all of these in the slides. That's something I meant to do here. I'm also going to share these with everyone, share these slides. All right, copy. And then let's paste these in the chat. There we go. So if anyone wants to look at these later or as they're doing the hands-on part, feel free to look at these. Pythex, this will use Python regular expressions because there are a few different standards for regular expressions. This will use the Python regex standard in particular to look at your any test string you give it. repl.it will let you edit Python code. And these are the two tools, the only two tools I think we need for this right here. So the first thing to notice is, let's see, I want to make sure I can get anywhere. So let's try Lawrenceville, 30043. And that'll give me Lawrenceville. Notice it puts the zip code right up here in the URL. So I'm going to copy this. I'm going to come over to my code. Requests is a Python library for handling web requests. So it'll take a URL and get the HTML from it. So right here, I want to do two things. I'm going to say URL equals this, but I would like my I would like this to work with any zip code. So I'm going to say zip code equals, I'm going to grab input from the user. So I'm going to say enter your zip, and then they'll type in their zip code. Then I want to insert that variable right here. So I'm going to make, there we go, and I'll say plus zip code plus, there we go. So now our URL is going to contain whatever zip code they entered. And then I'm going to use requests to get this URL. And then our response is saved in this variable, res. And then I'll print out the response text. That's going to be all the HTML that I get from the web page. So if I run this, enter my zip code, so I'll say 30043, then here's all the HTML. Obviously, this isn't what we're looking for. What we want to do is we want to get stuff like this, the location and the forecast, today, currently, blah. So we're going to use regex to grab some of that out of there. So the first thing I'm going to want to do is get the page source. So view page source. I'm going to take all of this, copy it, come over here. I'm going to paste it into this guy. Now, I would like to see if, all right, so I can find right here. So I've got Lawrenceville in between H2, this, it has a tag here, div class location, and then we've got that closing div. Cool, so what I can do is exactly what I had talked about before. Put this here, and then we're going to go, and there's going to be an H2, and then this is the stuff that we want. Everything between the two H2 tags. And that should be good for this. Now, it's telling me that there's no matches. That is because by default, a regular expression only matches individual lines. This spans several lines. So you want to tell it that our dots here are going to also span multiple lines. So we say dot all, and here we go. We've got one match, Lawrenceville, and it's got, oh, I told it to go to the next H2, not to the closing H2. So if I do this, there we go. Awesome, we got Lawrenceville. So now that I have this, I'm going to copy it, and I'm going to bring it over here. So I've got the response.text. So I'm going to make a regular expression statement. I need to import the re library. Then I can say re.findAll. And I'm going to give it the regular expression I just came up with as the first argument. The second argument is going to be the HTML that we're looking for. And remember, we also needed to give it the, or what's that, right here. We also needed to give it the .all option. And that is going to go right here, re.dots.all. Cool. So this is going to grab our location. So location equals, all right, let me make this look a little bit simpler. Regex equals this, and then we'll just stick the regex right here. Awesome. So this will get us our location. Let's comment that out. So if we run this, is it down here at the, okay, enter your zip 30043. Awesome. That looks like it totally worked. We need to print it. Print location. Okay. So if we run this, 30043, cool. Now notice two things. It's got all this space from the first part. Notice over here in our source code, it's got a bunch of space before it. And apparently it's got a bunch of space after. So what we want to do is we want to get rid of that. And notice it's also inside a list. This method right here, find all, will provide a list of all matches, because sometimes you'll get multiple matches. So we're going to tell it we just want the first match. And we'll actually do that right here. We'll say location equals location. We want just the first match. And that's just going to give us our string inside of here. We're also going to get rid of the spaces around it. So that's going to be .strip. That will strip any white space. So that's a new line, a tab character, a space character from the outside. So now if we run this, 30043, and we get just Lawrenceville. That is perfect. That's exactly what we want. So we got the location. Get the location. So now let's get the current weather. So it's currently 62. So where is that? That's right here. This one looks a lot simpler. We're going to copy all of this. And then, so over here, I'm going to say currently is 62. And let's see. Okay, yeah, I'm guessing that this guy right here, this degree sign, oh, we're also using parentheses. Remember, parentheses have a meaning in regex, so we have to escape them. And yeah, okay. I'm guessing that's, oh, still not working. Let's find this in here. Currently, there are people typing. Okay, nothing over here. Okay. It's weird. Today. And it's not capturing anything. Okay, so it is highlighting that there, but we're not keeping it. So here we go. This is why match captures. There we go. Okay. So it's showing us our captured groups. Awesome. So we want to go ahead and put this back. We need to apply this, and then right here, let's put this guy. Awesome. There we go. So like I said, this right here, the period, asterisk, question mark, that'll get you through 90% of what you want to do. So all I did was I copied the part that I want to get, and then I replaced this. You need to put backslashes behind anything that could be misinterpreted by our regex. Since parentheses have a special meaning in regex, we need to escape them. Then I replace the stuff that I want with parentheses and this guy, that little magic pattern. And then it outputs 62 as the stuff that it's capturing, the stuff that it's keeping inside our parentheses. So again, going to do the same thing. Come over here, regex equals, and I'm going to give it the pattern that we just came up with on that website. And then do the same thing. I can just reuse this. Instead of location, we're going to say temp equals that, temp equals temperature. And then print the temp. All right, and we'll give it a little bit more info. We'll say current temperature plus temp. And then let's say print current location plus location. Cool. So if we run this, there we go. We enter 30043. Current location Lawrenceville, current temperature 62. Awesome. Cool. So that is a fairly basic example of how you'll take a website and we made it so that we can replace the part in the URL with our own little data, so we can make the zip code anywhere. We fetched the data from the website. Then we use this tool here, Pythex, to figure out what the patterns are. We did a combination of looking at the HTML, and then we came up with different patterns to be able to extract exactly the data that we want. And then we just print it out. Once we got the data that we wanted, we printed it out in a nice, easy to read format. And then we're done. So that's a real world case of using Python for, I think the slides keep going away. They do. Okay. But yeah, so that's a real world use case where we would use regex, Python in a meaningful way. So now comes the next part, the hands-on part. First, does anyone have any questions so far about anything that's been done, anything that's been said?
I wasn't really able to follow along with you. Would it be possible for you to copy the code that you did for this? Just
Yes, no, definitely. Let me go ahead and share this. So this will just be Pi Workshop weather scraper. All right. I think if we just do this, this will be easier. Here we go. Awesome. Okay, and then if I go here, I should be able to paste this. There we go. Okay, let me know if you're able to view that. I think you should be able to. Just using the link I gave you.
it works.
Awesome. Beautiful. Cool. I think it actually lets you view any changes I make to it in real time, I think. I love this tool, REPL.it. It's good for collaboration if you and someone else want to work on some code at the same time. Okay, so for the next part of this, we're going to go ahead and do the hands-on part where everyone basically goes through the same process. I'm going to give you a website, and the goal is going to be for everyone to do the same thing. Build a Python script that goes through it and take some data from the website, and then outputs. Let's see, where is it? Here we go. Live demo. Okay, mini challenge, and then output some meaningful data based on what they get from the website. So what we're going to use is this guy right here, Extreme IP Lookup. You give it an IP address, and it'll give you information about that IP address, the ISP they're using, and the IP location where they're at. So it should be the same basic sort of thing. Please definitely use the code that I've already provided as a starting point. You can use the same thing, enter, change it to enter an IP address, and then insert the IP address into the URL, and then take all the HTML and parse it. If we look at this, cool. So it tells you about, this is my IP address or something really close to it. So yeah, it gives you the city, my country, latitude, longitude. It tells you that I'm using Comcast cable, unfortunately. And if we look through the HTML, let's look for like some of the stuff that we want to keep. We want to keep, say, Comcast. And here you'll find all of the information that you want to keep. So then you'll just need to come up with some regex statements to help you get this data out and print it and display it.